And welcome back, science fans. And here we go for round number 2. This is chapter 6, 6.1. We're talking about reactions. These are the 6 reactions you're going to learn: synthesis, decomposition, double replacement, single replacement, neutralization, and combustion. These 6 are going to be on 6 different slides we're going to be talking about. And at the end of this chapter, which is probably in 20 minutes, we want you to be able to do something like this. Maybe 30 minutes. See a reaction and going, oh, that's a combustion. And looking at this and seeing that's a synthesis. And looking at this and seeing that O2 is swapping with the Cl here, and seeing that is going to be a single replacement. And seeing here, this is going to be a double replacement. We want you to be able to identify the reactions, and then not only identify them, but also predict their outcomes. So this is just by the left-hand side, you can tell that this is going to be a single replacement, and the Na is going to swap with the Fe. So then we'll have the NaBr, and the Fe will be left alone. And over here, you can see that this is an acid. As we've learned acids, it starts with an H, and this is a base. So this is a neutralization. And what do we get when we have a neutralization? We get a salt, which will be the NaSO4, and water, H2O. And then we have to balance this and then balance the whole equation. And this is just going to be a combustion. And with combustion, we get carbon dioxide and water, H2O. Let's undo that, H2O. And then you have to balance it. So that's what the end result is. In a half an hour, you'll be able to predict what they're going to be coming out of each of the 6 different types of reactions. So we're going to learn these 6 different types of reactions and be able to classify them. And that's the culmination of the Science 10 that we're taking right now in chemistry. We want you to be able to do these reactions and predict them. Okay? So let's zoom out to there, and let's go to your first slide. Okay, so copy down the red, and here we go. Synthesis reactions are also known as formation reactions. There are two or more reactants, and they join to form a compound. So algebraically, it looks like A plus B becomes AB. Okay? The elements may form ionic compounds, like the following one. This is a sodium metal and chlorine gas combining. So we have two sodiums and a chlorine gas, and it produces sodium chloride. And this is a synthesis. But it could also be a metal reacting with oxygen gas. And here we go. And that is 2 magnesiums and an oxygen producing magnesium oxide. That's a synthesis. Both of these are ionic compounds. But it could also be making a covalent compound. A covalent compound could be nitrogen gas and oxygen gas joining to become dinitrogen monoxide. So there's a single element here, and now there's the compound. In this case, it's a covalent compound. So that is synthesis. That's the end of our first slide. Let's go to our next slide. Chemical, we're going to do the opposite of it. The opposite of synthesis is decomposition. And it's just taking a single compound and breaking into its components. A single compound, AB, breaking into A plus B. So it could be the ionic compound decomposing, like table salt, which is sodium chloride, can break down into a sodium metal and chlorine gas by actually melting it at 800 degrees Celsius and then running electricity through it. So we get the single compound becoming two sets of elements over here, and that's decomposition. Or we could run electricity through water and take the one compound of water, H2O, and breaking it into hydrogen gas and oxygen gas. That's decomposition. Let's move over to our third slide now. Single replacement. This one is one of the harder ones because there's two different types of it. It's sometimes easy to see, but hard to see exactly what's going on. So we have replaces one element from a compound. All it does is replace one element of a compound. Okay, so we could have a metal joining a compound. Now this compound is going to be ionic, and it's going to replace the metal. So the metal of B and C as a compound, B would be the metal. So it replaces the B. So the M replaces the B. And here, if it's a non-metal and that compound, the N is going to replace the non-metal. So the non-metal is the C, the second part, because it's always a metal and a non-metal in an ionic compound. So this C was where the N was. So there's two different types of single replacements. These are single replacements. When a metal A, let's just change my pen size here. So when A is a metal, okay, so we're going to look at an example here. Aluminum foil is a solution. Aluminum foil in a solution of copper 2 chloride produces solid copper and aluminum chloride. So we have a metal. Aluminum is a metal. And we have a compound. So what's going to happen is, of this compound, the metal is copper, so it's going to replace the copper. So we take the copper out, and the aluminum goes in. Then we have to do all the balancing. Okay? The second option down here is when A is a nonmetal. So when fluorine is bubbled through sodium iodide solution, iodine and sodium fluoride are produced. So here, take a look at this. This is fluorine, okay? And that fluorine is bubbled through. That is a nonmetal. And it's gone through this compound, so it's going to replace the nonmetal. Because it's a nonmetal, it replaces the nonmetal. So the nonmetal comes in here and kicks it out. We get the iodine coming on out, and the fluorine is replacing it. So that's where it was replaced. Okay, so those are all single replacements. Now let's take a look at predicting right now. Now that we're seeing this for the first time, let's predict it. Yes, these are not on your notes. You could jot them down to the side or just watch. This is lead is a metal. So of this iron sulfate, which one's the metal? The Fe, the iron. So the iron's going to come on out, and we're going to get Pb and SO4. Now we will have to balance that. That's not going to be the correct compound, right? There could be. Okay, let's take a look at this. NaF and Br. Br is our single element. And that is what? Is that a nonmetal or a metal? Anyone? Non-metal or not metal? It's a non-metal. And where would you find that out? You'd find that in the periodic table. Okay, so it's going to replace the non-metal. So this is going to become Na and then Br. You'll have to definitely balance that if that's not it. Okay, and so Br is the -1, and sodium is the 1. So that is balanced. So, and then we have to have fluorine. But, oh, fluorine, Fl. Whoops. My bad. Fluorine is F. Why did I do, oh, that's just a typo because it came over there. Get rid of the L there. Fluorine, but we know it's a diatomic, so we have to put a 2 there, and then you now have to balance it. Okay, and I think a 2 goes here, and a 2 goes here, and that's a 1 and a 1, and that balances it. We could have this single replacement, and that is a metal. So what does that replace? The H or the Cl? The Cl is a nonmetal, so where the hydrogen is the metal, so this is going to become hydrogen gas and aluminum chloride. But aluminum is 3, so then now we have to balance that. But I'm just saying this is how we start balancing it. Okay? And then we have Ga and F, and that's cesium. So cesium is going to replace this gallium because cesium is a metal. So that's going to become cesium and then fluoride, and then what we're going to have over here will be gallium. Now you have to make sure these compounds are correct. But that's what we're talking, this is our first step. The Br replaces the Cl here. So that's our third of the 3. Double replacement, our fourth type. A double replacement, if we have an AB compound and a CD compound, that's metal, nonmetal, metal, nonmetal, what happens is the nonmetal switch, or if you want to talk about it, the metal switch. They just swap their reacting pairs. So this one's pretty easy. It's complicated in that there's a lot of stuff to write, but in this case, the B and the D just swap. So it can be lots of different things. Things can be pulling on out. So we could have a solution and a solution, 2 liquids mixed together, and we get a solution and a solid. So we get something falling out, dropping out, becoming a crystal inside a liquid. Okay, and that is what a precipitate is, things that fall on out. A precipitate. So ideally, we look at it, we see a K and a CrO4, and an Ag and an NO3, and an Ag, a CrO4, and a K and an NO3. So you see the NO3s swap. The NO3 had silver beforehand, now it has the potassium. That's all. That's how you do a double swap. And that is a double replacement. So this is a DR, a double replacement. Now we have a special version of the double replacement, and it's one that you're very familiar with, and that's neutralization. Neutralization is a double replacement, but it's a special type of double replacement that it has an acid and a base. So we already know this one from last chapter. This is called neutralization, is when an acid and a base are mixed together. It creates the salt and the water. We already know how to do this. We've been doing this. This was chapter 5.1. So we have the acid and the base. We create the salt and water. As always, here to observe, you guys, it always has water. So that's a quick way to determine if it's a neutralization. And it's an acid and a base. So this is a neutralization. This is a neutralization because it's acid, and that's a base because it has hydroxide. That produces the water, and then we get the Fe and the PO4. The last type of reaction is combustion. This one's going to drive you a little crazy, but it shouldn't because there's three prescribed things in our reaction. We're always going to have oxygen. We're always going to have carbon dioxide. And we're always going to have water. Those three things have to be there for every combustion at the Science 10 level. Okay, and we're going to be basically just burning up hydrocarbon combustion. The objects are going to have a hydrocarbon up there. That's what they call that. Just carbon and hydroxide. And now sometimes it could be an alcohol. C6H12O6 is an alcohol, but it's a hydrocarbon with oxygen on top of it. So basically, just take a look. Oxygen, carbon dioxide, water. Oxygen, carbon dioxide, water. Oxygen, carbon dioxide, water. Those are all combustions. Okay, and the next slide is a summary slide. This has all six right here. We have the synthesis, the decombustion, the single replacements, the double replacements, the neutralization, and the combustion. Okay, so at this point, you could review it this way. You have one more slide there? Can you work on that, please, and identify them? And thank you very much. Remember, smash that like button, subscribe, leave comments below.